The Ford 2.7 liter EcoBoost is built like a diesel, is what I want to talk about in today's video. Welcome to DS Trucks. I want to talk about this because it's come up a number of times in the comment section. The 2.7 liter EcoBoost by Ford in the F-150 among other vehicles is built like a diesel. I've seen a lot of comments about it, and I want to talk about that. Is it built like a diesel? Like, what does that really mean? Well, number one, it has a material that diesel engines tend to have nowadays. Compacted graphite iron. It's stronger than just a regular old iron block. But how is that like a diesel? Well, it's kind of interesting. I don't feel like the 2.7 EcoBoost, as much as I love the engine, I don't feel like it's built like a diesel. Let's just look at the 6.7 Power Stroke, because it's a Ford engine. It's similar. You'd think they'd be built kind of similar. They both use the same material for the block, but that's where it stops. They're not similar beyond that. I believe this engine was designed by an outside company. The 2.7 EcoBoost was designed by an outside company. Maybe somewhere in Europe. I forget the name of the company. The 3.5 EcoBoost was designed, I think, by a different company. Correct me if I'm wrong. But the 6.7, I'm pretty sure that was designed in-house. But they're different. The 6.7 is a pushrod V8. This is a twin variable valve overhead V6. It's made from the same material, but the compacted graphite iron is used differently in this engine compared to how it's used in a diesel. One of the things to look at is the overall weight of this engine. This engine's the lightest, one of the lightest engines that you can get. I believe the 3.5 is the heaviest engine. The 5.0 is lighter than the 3.5 actually, and the 3.3, I'm not sure. I haven't done a lot of research on the 3.3. The entry level, the lowest level, I would say lower than entry level. I would say the 2.7 is entry level and the 3.3 is lower than entry level. Now, the way that iron is used in this application is used very lightly, meaning that it's designed to take advantage of the strength of the material, not to be over-engineered like a diesel typically is. It's used minimally, and it's really used in a way to save weight and not to be over-engineered and strong like a diesel. So while it does have the same material that a diesel typically has, it's not used in the same way. A diesel usually is built heavier than the gas engine. For example, looking at the Super Duties, if you opt for a diesel in a Super Duty, then your engine is going to be about 800 pounds heavier than it is compared to a gas. Now, some of that is your emission system. Some of that is your diesel particulate system. It's all that stuff underneath that adds weight, but it's not going to add that much more weight, maybe a couple hundred pounds. Most of your weight is because that engine block is so much heavier. The diesel still has aluminum heads, but the diesels run so much more compression that the engine block is typically heavier. Your crankshaft is heavy. Everything's heavy. Everything's built large and heavy. In the case of the 2.7, to say it's built like a diesel, it's not built like a diesel. It's really not even built like a 3.5 EcoBoost, where the 3.5 uses a stronger connecting rod than the 2.7. I believe a stronger crank is also in the 3.5 EcoBoost. It has a forged crank. I don't remember the crank in the 2.7. It might be forged, but I know the connecting rods are powdered metal compared to a forged connecting rod in the 3.5. The one thing about this is the water-cooled exhaust manifolds, and that's something that I wish Ford would put on all their engines, but I think there's honestly a limitation when you think about water-cooled exhaust manifolds, and I think the limitation is cooling. in order, I think, now correct me if I'm wrong, but in order to really implement a good water-cooled exhaust system, you want to have a smaller engine because of the extra demands that it puts on the cooling system. Now, if you ever look at the specifications of the cooling systems in the F-150s, the 2.7 has like an extra, I want to say an extra quart or something of coolant compared to the 5.0 and compared to the 3.5. And it's probably because those water-cooled exhaust manifolds hold extra coolant in them, so it has actually a higher capacity. But I believe that these water-cooled exhaust systems put a bigger demand on the cooling system, which in turn means that if you were going to do like a 5-liter water-cooled exhaust engine, it might be too much demand for the cooling system. Though I don't know. I think it'd be cool to see a water-cooled exhaust on some more engines, because it really does take the power to the next level. But it probably, in order to really get the power to go to the next level, it probably needs to be in conjunction with direct injection, with twin variable valve timing, with everything. Everything needs to be in line in order to get the power and use out of the 2.7 EcoBoost. Now, I don't want to bash the 2.7 EcoBoost, but I do just want to point out that it isn't built like a diesel. It uses the compacted graphite in a different way. The whole block isn't even compacted graphite. It still implements a lot of aluminum. It's actually a dual section block where the bottom half of the block has a different material, and the irons usually, I think the irons actually centered around the pistons. So not really built like a diesel, not built as strong as a diesel. I think it's built just right to be reliable in the application that it's in. I think they have a very good track record where they're not really blowing up or having issues or anything like that. But I don't want to put out there that it's built like a diesel, but that it does have a portion of the block that is compacted graphite iron. That is the same material that a diesel uses. Now, which design is better? The Power Stroke design or the 2.7 EcoBoost design? I think the 2.7 EcoBoost is one of the best designed engines as far as power per cubic inch. Is one of the best engines out there. It makes more power per cubic inch than the 3.5 EcoBoost, and obviously the 5.0 Coyote. It makes more power per cubic inch than both of those. In fact, if a 5.0 Coyote made as much power per cubic inch as a 2.7 EcoBoost, it would probably have like 600-700 horsepower. I don't know offhand. But if it made as much power as a 2.7 per cubic inch, it would be insane. Now, which engine's designed better? The 6.7 Power Stroke or the 2.7 EcoBoost? I like how the 2.7 EcoBoost is designed. It has the water-cooled exhaust manifolds, which makes it such a more compact engine. Your turbos fit right there on the side, so all your heat is centered in one spot, and it also provides a really good turbo reaction because you're so close to your exhaust, so you have less turbo lag. Water-cooled exhaust controls heat better right next to the turbos, so heat management I think is better. In the 2.7, you have twin turbo versus what like the 6.7 is a single turbo. So the twin turbo I think is superior because you have two small turbos which spool up fast, but when you take into consideration how much volume two small turbos can flow, well, they can flow volume like one big turbo. So smaller turbos spool up faster than bigger turbos, yet two small turbos is a good thing to have because you have the ability to spool and you have the benefit of having two instead of just one. So I think they spool up quicker, and there's the fact that you're multiplying it by 2. I think one of the things to consider is the twin variable valve timing gives you a lot more control over the valve train, which makes more power, it makes more torque, it makes all that stuff, which is great. The 6.7 Power Stroke does not have that because it's a push rod engine. But that being said, could you implement a dual overhead cam twin variable valve timing setup on a diesel? Probably, well, definitely you could do it, but would it be robust enough? you know, thinking about how well built a diesel has to be and the work that it goes under, could it be done? I'm sure it could be done, but could it be profitable and all that stuff when it really isn't necessary, considering the new 6.7 in 2020 is making over 1,000 foot-pounds of torque. It's making like 1,050 foot-pounds of torque. So why would you, you know, if you laid out a V8, it was a diesel, it had the high compression of a diesel, but then it had twin variable valve timing instead of a push rod. That means it has to have a huge timing chain and everything has to be built. The push rod engine might be actually stronger because it has a shorter chain and it's more reliable. It can use one big gear instead of having VCT solenoids and moving parts that might not be as reliable. And the spring tension and all that stuff on the cams, it might be more of an engineering nightmare to have an engine that's a diesel built like this. It would be incredibly expensive and it wouldn't really be affordable. So the pushrod diesel, you know, it makes sense for the Power Stroke to be a diesel. The reverse flow on the Power Stroke is definitely different from this. I think this is better. This design here with the water-cooled exhaust is actually better than the reverse flow, where the exhaust comes out of the center on the Power Stroke and the intakes go in through the side. I think that's great, but I feel like this design is better. But anyway, guys, that's it for the video. I just wanted to make a topic of discussion here on DS trucks, where we run nothing but the best. Is the 2.7 EcoBoost built like a diesel? I don't think it is, guys. I think it's built like a really good gasoline engine. Yes, it uses the same material as a diesel in the block. A diesel typically has a full iron block and it's generally really heavy, whereas this engine's actually really light. It's the lightest engine, and the other engines are made of aluminum, so that kind of goes to show how light this engine is designed. It's not designed to be heavy or over-engineered in any kind of way like that. It's more, it's using the iron, I think. It's using the iron in a way that is taking advantage of the strength, but using it in a way to make the engine actually lighter. So anyway, guys, that's it for the video. Comment below. Thank you guys for watching DS Trucks. Hope to see you in the next video. Over and out.